Okay, so today's lesson is going to be on scientific notation. We're going to combine 10.5 and 10.6. Our first idea is going to take a number in scientific notation and take it to standard form, which is, standard form is what we're used to seeing, like the number 200 or the number 6,000. However, when we use scientific notation, the reason is we have a really big number or really small number, and it's just easier to write it this way. So some of the key ideas for scientific notation, if a number's written in scientific notation, what happens is it needs to be a factor, which is a number, and a power of 10. So if you look at, I'm going to look at the example down here. This is the factor. It's the number, and then it's multiplied by 10 to some power. The power has to be an integer, which means a positive or negative number only, whole number, right? And then the factor, the most important part is it's between 1 and 10. The factor cannot be a decimal, and it cannot be greater than 10. So those are the things that make it in scientific notation. So let's go to our first little check-in here. Let's tell whether the number is in scientific notation and explain. So the first thing I'm going to do is I'm going to look at the factor. Is this between 1 and 10? So my answer is yes, so that part's correct. Are we multiplying by 10? Yes, so that's correct. And then is this exponent here either a positive or negative whole number, meaning integer? And that's yes. So this is in scientific notation, okay? And an explanation, we just talked about it. We don't have to write it all out. It's because the factors between 1 and 10, we're multiplying by 10, and the exponent is an integer, positive or negative number. All right, let's look at C here. I don't know why I skipped B, but we're going to look here. Is this factor between 1 and 10? And the answer is no, it's not. It's actually greater than 10. This 0.4 means that it's greater than 10. So this is not scientific notation, and the reason why is the factor, which is just our number off to the left, it is greater than, that's my greater than symbol, 10. So it's not in scientific notation. The other stuff in there is okay, but just specifically the factor, if it does not come between 1 and 10, it's not scientific notation. All right, let's look at B again. Let's look at the factor first. Is this between 1 and 10? And the answer is no, it's not. Remember, we cannot have just a decimal less than 1. So no, the factor is less than 1. And then let's look at D. Let's see, my factor, yep, 9.72. It's okay to have the 0.72 as long as this factor here is less than 10. And then we have times, we have times 9. It cannot be. So this is the wrong part. So it's no, and it's not multiplied by 10, not times 10. We have to have 10 as the base over there that we're multiplying and raising to a power. So that's the first part of scientific notation, just identifying if it's in the correct form. Let's go to the next part. So we have some rules. So basically, you're given a number in scientific notation. If the exponent is positive, that means we're going to move that decimal that many spots, whatever the number is, to the right so that we have a larger number. So positive exponents means larger numbers. So with 8, I'm pretending that this says 8 point, because remember with a whole number, we don't always put the decimal point, so I can write it as 8.0. And then this is a positive 6, which means I'm going to move it right 6 spaces. Again, it helps that since my exponent is positive, I know I'm going to get a bigger number. So I know I have to go right to get a bigger number. So I'm going to go 1, 2, 3, 4, 5, 6. And then I have to fill these with zeros to make my number. So then I'm going to rewrite it on the bottom, nice and neat. 1, 2, 3, 1, 2, 3. And then I'm going to go put my commas in. So we start at the back of the problem back here. And every 3, we put a comma. So my number is 8 million. That's my final answer. I was just doing the work. So then if I look at, again, I'm going to look at the next one. Again, my exponent is positive. And this is the section where we're doing it that way. But I know I'm going to get a bigger number. Or also, you can remember moving left or right, but I think it's a lot easier to remember. If it's a positive exponent, you are going to end up with a bigger number, which means you have to go to the right, because if you went the other way, it'd be smaller. So I'm going to rewrite it down here real little, and I'm going to move my decimal point. The exponent tells me how many to go. 1, 2, 3, 4, and I have to hold my spot with zeros, okay? So then I just rewrite my number. When it's a big number like this, we don't really write decimals at the end unless there's more. And then I just go put my commas in. So I start at the back of the problem right there, and I'm just going to count every 3 and put my decimal. So that's 72,500. And then I have my next one. I'm going to look at 3.1 times 10 to the 5th power. Again, I have a positive exponent. I want a larger number. Positive exponent means I'm getting a larger number, which means I have to go to the right to get a larger number. So 3.1, and then I'm just going to move 5. 1, 2, 3, 4, 5, and I make those little marks so I know where to put my zeros as placeholders. So I get 3, 1, 0, 0, 0, 0. There's 4 zeros. So then I just go back to the end of my problem and I put my commas in, 310,000. So that is when we have a positive exponent. We want a larger number. So we go right. Now in the bottom part, if we have a negative exponent, whenever the exponent is negative, that's going to tell us we're going to go left. But basically, we want a smaller number. We're going to end up with a decimal. So a negative exponent gets you a decimal. If you remember that part, it'll always be easier to think, okay, which way am I going to go? Instead of remembering left and right, negative means a decimal. So if I'm right here at this number, 5.3 times 10 to the negative 4th, I'm still going to move 4. Negative tells me it's going to be smaller. So it's obvious if I go to the left, 1, 2, 3, 4, and I put my decimal there, my number does get a lot smaller. So I don't have to remember left or right as long as I remember negative exponent means smaller or decimal. We're getting a big giant decimal, okay? So this is 0.00053. That's how we would write it out. Let's look at number 6, the next example. We have 6 times 10 to the negative 5th. So when we write the number 6, we know that it's like having a 6.0, if that helps you think of where the decimal point's at. Again, when you have a negative exponent, that means you are going to get a smaller number, or also known as a decimal. It's going to be less than 1. So looking at this, if I went to the right, I would be 60. So that doesn't even make sense. So that tells me I know I'm going to go left. So I'm going to rewrite this 6.0 down here, if it helps to put the 0.0, but really we're going the other way. So I'm going to go 5. 1, 2, 3, 4, 5, and I put my decimal there, and then I fill these little spots with 0. And then again, this 0 after doesn't need to be there. So my final number is 0.00006. Very small decimal. I know that because I have a negative exponent. And the last example here, let's look at, I have a negative exponent. So again, I know that I'm going to want a smaller number. The smaller number is our decimal. So that's going to help me figure out which way to go. If my decimal point is here, I know if I rewrite it down here so I can do my little swoopy things, I know if I go to the left, I'm going to get a smaller number. So I'm going to go to the left 3. 1, 2, 3, and I'm going to put my decimal, and then I'm going to fill these two with zeros. So then my final answer would be 0.00943. Okay? Now I want you to take a minute and pause the video and go ahead and give these two a try. Okay, so these are the answers you should have come up with. The first one was a negative exponent, which means you were going to have to go and get a smaller number, which means you have to go this way, right? We're going to the left. We want a smaller number. And then for B, we had a positive exponent, which means we automatically get a larger number. So I know that it makes sense. I would have to go to the right to get a larger number. So just remember that. Negative exponent means a decimal or very small number. Positive exponent means a very big, large number. Okay? This is just part 1 of the video. You'll go on to part 2 because we are also going to do 10.6.